So yesterday we have completed the different methods to express the concentration of solutions, that is molality, molarity, mole fraction, mass percentage, volume percentage, parts per million, etc. Now we will do one more calculation. See, one question I have written on the board. Calculate the mass of urea required to make 2.4 kilogram of 0.25 molar aqueous solution. So first what we have to find out mass of urea. So molal. So what is the formula for molality? Molality, small m, is equal to number of moles of the solute, divided by mass of solvent. We need mass of solvent into in gram into 1000. This is molality m. Now what are the things given? We are given with a 0.25 molar aqueous solution. So molality is given 0.25 molar solution. Now what is given? 2.5 kilogram of solution. So mass of solution is given. Mass of solution is equal to, mass of solution is equal to 2.5 kilogram. That is equal to 2500 gram, right? So we are given mass of solution and mass of molality is given. Now what we have to find out? Mass of urea. Yesterday I told you the letter which denote mass of a solute is small w. So small w is mass of urea. Now molality m is equal to, that is equal to number of moles is W by mv into, now mass of solute is mass of solvent. How will you find out mass of solvent? Mass of solution is 2500 gram and mass of solute is W. So what is mass of solvent? Mass of solvent is equal to 2500 gram minus W. So you got mass of solvent. So 2500 minus W. Now into 1000. Now what is molar mass of urea? Urea is NH2CO NH2. That means 2 nitrogen atoms. So 14 into 2 plus 4 hydrogen. 1 into 4. 1 carbon. 12 plus 1 oxygen. 16. So 28 plus 4. 32 plus 12 44 plus 16 60. Okay, 60. So 60 is the molecular mass. Molar mass is 16 gram per mole. So W into 1000 divided by 60 into 2500 minus W is equal to, molarity is given 0.25. Now you can find out W, you solve for W. So that's how we can calculate the mass. So this is how we do like different calculations based on these different types of methods of expressing concentration. Now when you come to again, what is next? Solubility. What is solubility? See, solubility is the maximum amount of solute that can be dissolved in a fixed mass of this solvent to make it a saturated solution, or it is the amount of solute that is present in a fixed amount of saturated solution at a particular temperature. That is called solubility. Now I will go to the dissolving of a solid substance into a liquid. A solid is dissolved in a liquid. So what happens is, you dissolve a solid substance into liquid. The solid particles, I told you, they will split into different units, smaller units, and they go into solution. Now when these, that particles always collide each other when they move, when you add solute particles to it, the solute particles in the solution also will collide and some of them will come out of solution. These two are simultaneous. Neither when you dissolve a solute in a solvent, what happens is solute molecules will split into simpler units and then they go into solution. That process is called a dissolution. So solute particles will go into solution, that is called a dissolution. Now these solute particles, when they collide with each other in the solution, some particles will come out of solution. But solution they collide with each other. That is actually crystallization, the opposite of dissolution. So crystallization will take place. These two are always simultaneous processes. They take place simultaneously. They are dissolution, then crystallization. At some point, the rate of dissolution will be equal to rate of crystallization. Then we say that an equilibrium is reached. Then that means a maximum amount of substance is dissolved there. Now no more solute will dissolve in that. Understood? No more solute will dissolve in that solution. Then we call that solution as a saturated solution. Then that solution is called a saturated solution. So a saturated solution is one in which no more solute will dissolve at that particular temperature. At that particular temperature. Now when you increase the temperature, what happens? More and more solute will dissolve in it. So what happens? Again I will tell you. When a solid substance is dissolved in a liquid substance, the solid substance will split into simpler units. They will go into solution. Particles are split either. They will go into the solvent, and that process is called a dissolution. That process is called a dissolution. Now, when dissolution, the opposite process also takes place. That means the solute particles which are in the solution will collide with each other and they come out of solution. That is called a crystallization. 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 So this dissolution and crystallization, they take place simultaneously. So at some point, what happens is at that particular temperature, this two rate of dissolution will become equal to rate of crystallization. So whatever amount is dissolved, it is coming out. So that means maximum amount got dissolved. So then we say the equilibrium is reached, and then the solution is a saturated solution, a solution in which no more solute will dissolve. Then we call it as a saturated solution. At that particular temperature, the temperature must be fixed. If you increase the temperature, what will happen? The solvent molecules will move apart, more and more solute particles can enter inside, then the solubility will increase. Understood? The solubility will increase if you increase the temperature of a solid in liquid. It is the solubility of solid in liquid. The solubility of solid in liquid will increase when you increase the temperature. But if the pressure, we talk about pressure, one other factor is pressure. But pressure has not much effect on a solubility of a solid in liquid, because pressure, when you apply pressure, the molecules will not have any higher energy or they will not move apart. So pressure has no effect in the case of dissolution of a solid in liquid. But the dissolution of a gas in liquid has some other factors which will affect the solubility of gas in liquid. For example, you dissolve carbon dioxide in water. We know that to get soft drinks, they make soda and all. They dissolve carbon dioxide in water. With a high pressure, they dissolve in that. Then solubility will be more, and they will seal them in a bottle so that the pressure is not decreased. At that high pressure, they will seal the bottle so that the carbon dioxide will not escape. So that is when you increase the pressure, the solubility will increase. What about temperature? When you increase the temperature, the solubility will decrease, isn't it? The solubility will keep boiling for the water. After some time, the water, you can see bubbles coming up. What is that bubbles coming up? It is the dissolved gases escaping. That is, the solubility decreases when the temperature increases. That is why aquatic animals, they are very much safe in ordinary water. If it becomes warm, hot, then dissolved gases will escape. So aquatic animals cannot breathe, or they will not get enough air to breathe. So that is difficult. That makes them difficult to live in hot time in water. So we will come on to again this solubility of gases in liquids and the effect of pressure. And we know that when pressure increases, solubility will increase. Now the first man who started to study the solubility of gases in liquid is Henry, and he proposed his theory, Henry's law. It is called Henry's law. Now what is Henry's law? According to him, the solubility of a gas in liquid is directly proportional to its pressure. The solubility of a gas in liquid is directly proportional to its pressure. And Dalton, at the same time, he also proposed a theory. He said, if the solubility is expressed in mole fraction, if the solubility is expressed in mole fraction, then the solubility of a substance is a gas in liquid is directly proportional to its partial pressure. So we can express if partial pressure is P of the gas, it is directly proportional to the mole fraction of the gas. The partial pressure of the gas is directly proportional to mole fraction of the gas, or partial pressure P is equal to kH into mole fraction, and this kH is called the Henry's law constant. And this Henry's law constant for a particular gas will be different at different temperature. This law is applicable at constant temperature. So at constant temperature, the partial pressure of a gas is directly proportional to its mole fraction, or P is equal to kH into X. kH is called a Henry's law constant, and this Henry's law constant is a constant at a particular temperature for a particular gas. When temperature varies, the kH also varies. And for different gases, the kH value, the Henry's law constant value is different. Now for a particular temperature, for different gases, I told you kH value will be different. And for a particular temperature, then the partial pressure, if it is if we take it as a fixed one, then this will be, you see, as kH value increases, Xg will decrease, because partial pressure is a product of kH and Xg, isn't it? That is Henry's law constant and the mole fraction of the gas. This partial pressure a product is constant. If the value of kH is low, its solubility will be high. If the value of kH is very high, the solubility of that gas, that is mole fraction of the gas in liquid, will be very low. If kH value is very low, then the solubility of the gas in mole fraction will be very high. But for a particular partial pressure, that is a particular temperature, the solubility of a gas depends on its kH value. If kH value is very high, solubility will be less. If kH value is very low, solubility will be high. Gases, what they used to ask in question is, they will give kH value of certain gases at a particular temperature and pressure. Then they ask you to arrange them in the order of solubility. So if kH value is very high, then its solubility will be low. So from low to high, that means kH value high to low you will have to write. If kH value is very high, solubility is less. So like that we can arrange. Now what are the applications? There are very practical applications and industrial applications for this Henry's law. Henry's law, you can, as I told, the soft drinks, they all contain dissolved carbon dioxide, and this carbon dioxide is dissolved in water under pressure, and they are sealed under pressure. Then the gas will not escape. So this is one application. Then next one, says scuba divers. Who are scuba divers? They are deep water divers. Valare ulkadalilokke ingane dive cheyyunnavare. For them, they take gas cylinders with them. Now what really happens is, if that cylinder is contain ordinary air, if it is there, what happens is, when they go down, the pressure will be very high. So when the pressure is high, more gases will dissolve in blood. More gases will dissolve in blood when pressure is very high. When they come up, what happens is pressure becomes lower and lower, then solubility will be lesser and lesser. Then what happens? The gases try to escape from blood. So those which are not dissolved, that is nitrogen gas, etc., they will escape as bubbles. Bubbles will be formed in the blood veins. Then what happens is they create a situation called the bend that even leads to death. It is fatal sometimes. So to stop this, what they do is they fill or they increase the percentage of gases which are having very high KH value, that is solubility is much less. But dissolve ചെയ്ത് പോവില്ലല്ലോ, അപ്പോൾ pressure കൂടിയാലും gas dissolve ചെയ്യുന്ന quantity കുറയും. അതിനുവേണ്ടി they add gases, they increase the percentage of gases which have very high KH value. For example, helium. Helium has very high KH value. They increase the percentage of helium. Then they go inside. Much gases will not dissolve due to high pressure. Understood? So they decrease the percentage of those gases whose KH value is low. They increase the percentage of gases whose KH value is high, like helium. Usually they increase the percentage of helium. Then even at high pressure, only required amount of the other needed gases will dissolve. Understood? So that is another application of this Henry's law constant. So scuba divers who are going deep into the sea, for them what they do is they fill their gas cylinders with the helium, the air concentrated with the helium gas, because helium gas has very high KH value and its solubility is very low. So even under high pressure, only required amount of gases will dissolve in blood and no problem will come when they come out. That is, when pressure decreases, this type of bend that will not come. That is, bubbles will be formed in the blood veins and arteries. Now, another thing is, application is when people go up, that is in mountains, then also they carry this one. There again, when pressure decreases, when we go up, when higher, then pressure decreases. When pressure decreases, solubility of gases will decrease. Then what happens is, enough amount of oxygen will not be there in brain. Then that will cause again, the people cannot think reasonably, problems will come. So that also, then they will increase the percentage of oxygen and all in that, so that the brain gets more oxygen. So that is another application of Henry's law.